share regarding the discriminants? What did you pick out from the video that stood out to you? Noah?
If b squared minus 4ac equals 0, then this is only one solution.
Okay, well, first of all, yes. What is the discriminant? Tanvi?
The discriminant is b squared minus 4ac.
Good, b squared minus 4ac. And where is this found? Like, where's it, if you just want to look at the problem? Gavin?
In the radical sign of the formula.
Okay, good, so it's under the radical. And now, I'm going to switch to what Noah shared with us, that if you figure out the discriminant and you find that it's 0, that will tell you that there is one real solution to the problem. What if the discriminant is something other than 0? Dylan?
If it's below 0, there's going to be no solution.
Okay, let me revise that just a little bit. If it's a negative number, there is going to be no real solution. And I'm going to tell you more about that in just a minute because I actually think the video could have done a little bit better job going into the imaginary number. So if the answer is negative, there's no real solution. And what does the graph look like? How many x-intercepts are there if the discriminant is negative? Karis?
There's no x-intercept.
Excellent, good job. This has no x-intercept. So we have one other scenario. We can either have a 0 discriminant, negative discriminant, or Andrew.
Greater than 0.
Okay, good. Greater than 0 or a positive discriminant. And if that's the case, how many real solutions are there?
2.
Good. That's exactly right. And how many times does this parabola cross the x-intercept? Good. Excellent. Okay, so do you notice the number of real solutions matches up with the number of x-intercepts? Hopefully that's, okay, 2 x-intercepts. So naturally, one real solution means that there is, I'm sorry, I'm leaving no space, 1 x-intercept. Okay, let's see, that's all I have written down for what I found under discriminant. But would anybody else like to add anything to the discriminant notes before we move on to the next? Okay, great. Let's talk about imaginary numbers. Have you guys talked about these at all? Dominic, what do you think?
I talked with, to my dad, we had the answer was the square root of n for a problem a while back. He was like, have you guys talked about I yet?
Okay, great. Sophie?
It caused a crisis last year in our math.
Oh my goodness, what was the crisis?
Well, it was just, we were just yelling at Mr. Piggott about it, and we're like, it doesn't make any sense, and because he was trying to explain it to us, but not explain it to us.
Did he do, I bet he showed you I squared equals -1. Did he show you that?
I don't know, but he
Okay.
had something where it came up, but he wasn't able to explain it to us because we had to do it.
Okay, one of the things that I wish we had time for today, but we do not, is there's an excellent Khan Academy video that goes into how the different variations of raising I to a power, but we just don't have time. So what I will tell you in super simplified version is that I is the imaginary number. It's kind of like a lowercase cursive I. So this represents an imaginary number, which is important because we talked about, we might have a discriminant that's negative. So what do we do? I'm just going to pick at random, negative square root of 57. Well, you cannot multiply real numbers to get a negative. I'm sorry, you can subtract something to that. You cannot multiply two real numbers together to get a negative product. You can't square two numbers to get a negative product. That's where imaginary numbers come in. So this simplifies to, for instance, if on one of your homework problems you got square root of negative 57, you move the negative sign in front of the radical to show that it's not a real number, and then you're left with square root of 57. and I'm not gonna go into, because I don't have time, why you can do this, but that's, the I goes to the outside representing an imaginary number, you're left with a positive square root of 57. And since this is not a rational number, you leave the radical, but I know some of you are thinking, what if you have a perfect square, like for instance, negative 16? So what do you think? Turn and talk to the person next to you. How do you think you would represent this using that I?
Because if you simplify it, then what would you do? But then it's not square rooted anymore. It should be I square root of 16.
Okay, I want to do a class poll. I've heard two different things. Well, actually, I've heard no, I don't know too, but that's not one of the options. You're going to choose between, I heard somebody say you have to leave the I, so you would do I negative square root of 16, and I heard somebody else say 4I or I4. I think they said 4I. They might have said I4. So these are your two choices. I leave the radical at negative 16 or 4I / I4. Right, so choice 1 or 2, we're doing a class vote, just hold up 1 or 2. Okay. I see more 2s than 1s by a little bit. So I will tell you that that is correct. If you can get a perfect square, you do the perfect square and just put the little, this is actually more precise than the other. So this would be, you do the real number followed by an I. So you'll probably encounter both an irrational and a rational negative under the radical side. So now you know both ways to represent that. Okay, what else do we know about an imaginary number? If it's imaginary, it has how many real solutions in these problems that you'll look at today? Dane?
No real solution.
Yes. So an imaginary number is going to show no real solution. And because there's no real solution, how many x-intercepts are you going to see? Let's come back to the chart here. Right, very good. Okay, so imaginary number indicates to us there is no real solution. What else? When do we